Hi FMEers, it's Mark here. Funny, this morning I was asked to look at some training materials that we're putting together all about lists and how we can use lists to avoid loops or do loops better. And I was sort of thinking that over in my brain and gave some feedback. And then I looked at the Advent of Code competition where I'm up to right now, and currently most of the tasks I've used loops in there, but I think this one is possible that it could be a list or the cloner or something like that instead of using a loop here. So here we're trying to I'm not quite sure what the technical term is, but we're trying to find the best result for a different series of positions of these little sort of crab submarines. They're sort of in a horizontal line, and we want to line them all up, and we want to find out which sort of position on the x-axis gives us fewer movements to get them in a vertical line. And I thought, well, hey, I mean, there's so many ways we can do this. But if I'm going to use FME, which I obviously am, then I'm thinking maybe we could use the length calculator to measure the length. But then normally you want to do this in a loop and sort of measure the length of each feature and loop through them. But I think we can use the cloner. Maybe a list, maybe we don't need a list to do this. So I'm going to fire up FME and give it a shot and see if we can do this. So let's see. So I'm just going to sort of make FME a little bit smaller just so I can see what's on the screen on the Advent of Code bit. So I'm going to use their test data first just to do that. I'm going to create a feature. I'm going to add an attribute. I'm going to call it original crabs for want of a better term. And I'm going to copy that into here. And we are going to use the attribute splitter to split that up. And that's going to give me a list, which I'm going to explode straight away, I think. But we'll just say keep crab list exploder. And explode crab list. Actually, what I should say is, instead of calling it crab list, I'm going to call it crab position, because when I explode that list, it'll come out with the attribute called crab position, which is really what I'm trying to get here. So let's see, list index. I don't know that I need that, but so that should explode that into a different feature per crab submarine. So we've got 10, and we've got the different crab positions there. And what I'm thinking, because these sort of little mini submarines, I mean, it's a strange scenario, but they're supposed to be sort of floating horizontally in the water. So I can create a vertex for those. And I'm going to say, replace with point. X value is crab position, and the Y value is, we'll just go with 0, because it doesn't really matter. It's all the same. It's got to be a constant. And now, what I think I'm going to do now is this idea of a cloner. Because I mean, I could create a loop and sort of loop through it a number of times, but I'm going to clone these. one for each position. So what I'm going to actually, yes, I need to find the largest of those numbers. So I'm going to analyze the crab position and find the maximum. And I'm going to assume the minimum is always 0. I mean, I know it's 16 in this case because that's the data, but then I'm going to do a cloner. Number of copies is going to be the maximum crab position, and then we've got copy num. That, I don't really want the graphics right now. So copy num 0. So that's going to be my sort of positional loop. So now I'm going to add another vertex. Well, this can actually be really straightforward to do. I'm going to add another vertex, which is going to be, so copy num is going to be each position. So add a point, copy num 0. And that should create me all of the different lines in all of the different positions. Wow, this might actually, yes, be very, providing I've got this right. Length calculator. So I'm going to calculate the length of all of those lines. And then I'm going to sum it up. And I was thinking I might need a list, but actually I can just do an aggregator. So we're going to aggregate it, group by, what do we call it? Copy num. And attributes to sum would be length. And we should get 10 items out of here. And the one with the lowest value for the length in total, 37. Yep, there we go. 37 is copy number 2. Position 2 is 37. Position 1 is 41. Position 10 is 71. Ha! Bingo. Wow. I am shocked. That, well, I mean, I shouldn't be shocked. I mean, I know FME can do this, but wow. Yeah, first time out of the barrel, as it were. And that's, yeah, I'm really happy with that. Well, let's try with the full data set, which is this. See, I've had problems before when I've scaled these up. Oops. When I've scaled things up, it's tended to go so slow. But I'm thinking that was because of lists, and I'm hoping that we won't have the same problem here. Okay, so what I should do with that is put a sorter on there. Sort by length, numeric, ascending, and then we'll just put a sampler down. Grab the first feature, and that should be our result. So let's see how fast this goes, excuse me. Clone a vertex creator calculator. Yeah, I'll just tidy this up a bit, I guess. It seems to be going fairly quickly. So there's 1,000 elements there, and I'm counting from 0 to what's 1,400, 1500, 1800. So 1800 times 1,000, 1800 would be 18,000. Is that 1.8 million? Yes. Okay, so I'm 300,000 out of 1.8 million. But I mean, it ran on the original data, okay, so I can't see that it would be a mistake. What I should really do now, of course, is start tidying this up while I'm working on it. So create source crab submarines. Create sub vertex. Find maximum offset submarine. I mean, it's such a strange scenario that I doubt I'm going to come back to this and figure these labels will be any help anyway. But so this the cloner is the key here. I'm creating what. So we're trying to find which X value works for all of these subs, and what I'm doing is I'm creating a set of data for every X value. That, in essence, is what's happening there. And then we create the vertex to that X value. Line from sub to X value for that clone. Calculate the length of all lines. I hope I'm not creating a list in the aggregator because I really don't need to. Actually, what I should do as well is save this workspace because that would be very bad if something happened. And I'm so glad that they made it you could save your workspace while it was still running. Sum up values, grouping by each X. Sum up length, offsets, I guess we'll call them. Oops. Yeah. Sometimes I get this problem where it's still, that label is still selected. Sort data to get smallest distance first. And we'll do the sampler just to get that first distance. The trick I've noticed in many of these puzzles is you create a solution for it's in two parts, and you create a solution for the first part, and it works just fine. And then you read the second part, and yeah, it's a totally different method that you need to use. So I'm hoping whatever part B comes up with, I can still use this method. I'm wondering if they might use might apply Y values or Z values, I guess, whichever way you look at it, so that each submarine's got a depth as well as a horizontal position. But I'm not going to know that until I put the answer in, and hopefully it's the right answer. But yes, very weird scenario in case you were wondering what we're trying to do here. think that's, assuming it works, this could be one of the quickest I've actually solved one of these puzzles. So we shall have to see if it is correct. And if I'm right, we should be up to about 1.8 million in total. I mean, this does seem to me to be inefficient because we're creating so many features, and I wonder if it's not necessary to do that. But I mean, I put this together really quickly, so it, I guess whenever you do some sort of work, you've got the offset of the time you put into it against the time that you're saving. And here it's running slower, but I didn't use as much time to create it. So, I guess we can see here 970 out of 1,000 features are done. We're getting close. And fingers crossed. Ooh, no. Oh, yeah. Yes, that's right. There we go. I don't really need to cache all of the output I didn't need. So there we are. The answer is 313. And that gives the minimum length 335271. If we looked at the sorted data, yeah, I mean it's... Well, there's only one way to find out, and let's put the answer in here, 313. Oh, man, too low. Hang on, what am I trying to do here? Am I trying to put the... How much fuel must they use? Okay, there we go. So it should be 335271. Okay. Oops. That's what I'm looking for, not the... Okay, I've got to wait 30 seconds now because I didn't read the instructions. Oh. Well, that's just me, isn't it? So, it must be down to 20-something seconds now. We'll be here. 335271. Count down 5 more seconds and hit the submit button. 4, 3, 2, 1. Hey, excellent. Whew. We got it right. So continue to part 2. Let's continue to part 2. I mean, I showed what I wanted to show really, which was how to use the cloner to avoid using lists. And that goes back to this technique I created 2014. Wow, so 7 or 8 years ago, I guess. And it was basically, well, instead of using a loop, why don't you clone a feature? So if I wanted to create 10 concentric circles, I could go through a loop and just sort of increase that distance every time. But I could just clone the thing instead and use the... because the cloner returns a number that tells you the number of that clone, we could multiply that by a distance to get our concentric circles. And that's how that would work. And then I did a similar thing here that cloned the CSV data. Again, what we're trying to do here is create a copy of all of the data for all of the features. And so the better explanation perhaps is this. We've got all of the soccer grounds in the UK, in the Premier League anyway, and we want to draw a line from one to the other. So from Stadium 1 to Stadium 2, from Stadium 1 to Stadium 3, Stadium 1 to Stadium 4, and so on, and then Stadium 2 to 3, 2 to 4, 2 to 5. And so what I did, instead of looping through things, because you'd think, well, maybe I should loop through like a double loop, a nested loop, where I take Stadium 1, and then I go through 2, 3, 4, 5, 6, and create that connection every time, and then go to Stadium 2, and loop through the others and create that connection. So that would be a nested loop. And instead of doing that, what I did was I just merged all the features together into one and created a list. So now I explode that list, and then basically I've got one feature per source stadium, and then I've got an entry in the list for every one of the other stadiums that I need to go to. So I explode that list again, and then get all those vertices made up for me. So I don't have to do any looping through there, and it's just way quicker that way. Okay, so see, this is where we figure out that this is not the solution we had is not going to work. Submarine engines don't burn fuel at a constant rate. Each change of one step costs one more unit of fuel than the last. The first step costs 1, the second step costs 2. So basically, as we're moving this feature along, it's getting more expensive. Well, that's okay, because again, I'm going to go back to the old data set, the test data, because I think, yeah. See, I'm thinking that shouldn't be that difficult, because it's the length, and we just multiply it. But is there a mathematical way of doing that? That's what I got to figure out there. It goes 1, 2. So 1, 2, 3, 4, 5. If it went 5 spots, it would cost 1 plus 2 plus 3 plus 4. Okay, so it's the, what do you call it with the exclamation mark? And I'm sure I've got that somewhere. What do we call it where you sum a group of numbers up to a certain number? Now I've got to figure out what it is. Sum numbers to n. What do we call it? I can't remember the... One plus 2 plus 3 plus 4. That looks right. Maybe I'm thinking multiplying. There's got to be a... Oh, see, my brain's going, like, what do you call it when you do 5 exclamation mark? Like that. Like, what is it? What's it called? No, that means not. Anyway, I think that's wrong, because 5 with that number isn't 120 if it was adding it up. So how do we add numbers together? What's the nth partial sum of the series is a triangular number. Wow. Well, this is going to make this interesting. There's got to be a... Like, is there a custom transformer? List summer. Huh. I'm just thinking I could create a list. Like I could create a list of values from... I mean, I guess that's what I'm trying to do here. So how do we create a list? Can I do a fixed date time? Yeah, I think I probably can. I was just online today because I thought, hey, I just wanted to do that puzzle, and I thought, hey, what the heck? I'm gonna just stream it while I do it. Okay, how to sum the integers from 1 to n. Okay. Okay, that's not really what I saw there. The formula for the sum of first n positive integers, n multiplied by n plus 1 divided by 2. Is that right? 5, 30, 15, 10, 15. Yeah, that seems seemingly right. So if that's the case, instead of the length calculator, I can just do an expression evaluator. And instead of n, it would be a copy number. Now, is that going to run? Is that a valid expression? Let's see. Underscore length. I'm going to save that as day 7b solution and hit the run button. And what should it be? It should return 168 as the lowest value. What have we got there? I don't seem to have got any length. Null. Okay, so value of that multiplied by plus 1. Okay, let's see if that works. Length, okay. So we're looking for, okay. We're aggregating it together. Why have we got 0? Oh, I actually want the length in there, don't I? Because the length is what I'm trying to... So if the length is 5, then it's length multiplied by length plus 1 divided by 2. We'll get there. And that gives us different result. Okay. So now instead of summing length, we need to sum result. And then sort by result. And there we go. Let's see what we get out of this. Result 168. 168. Bingo. And position 2 now costs 206 fuel. Excellent. So now all I've got to do is stick that value back into my attribute and let it run for about 10 minutes. And that should be what we want. Well, that would be, again, would be quite, I'd be quite happy if that finished, if that actually worked. I mean, I don't see why it shouldn't. But this was one of the simpler workspaces to put together. Even if it is going to take a few minutes to do this, we're feature number 47 out of 50. Maybe I should be quicker if I didn't cache everything. Let's stop that. Connect that to an inspector. Turn off caching and rerun. See if that makes it quicker. I'm always paranoid when I do this that I'm not going to get output and I'm not going to see it, and I've got to run the whole thing all over again. I don't know if this will run faster without caching, but I mean, I think it will, but I don't know how much faster, because I mean, it is creating something like, what were we saying before, 2 million features. So 2 million, 4, 6, 8. So yeah, it's caching 8 million features. Even if they're not that large, it's still, yeah, this is running way faster than before. Because we're up to 250 features already out of 1,000. So, yeah. Yeah, that's looking faster. And maybe there's faster ways than this. I mean, really, do I need to create vertices? No, not really. I could just calculate the value, the length being the value minus 0. I mean, well, the value minus the clone number. It's not like I need to really use spatial features here, but when you're using FME, it's like, well, okay, it does spatial, so let's do spatial. You sort of feel guilty if I was calculating lines and the distance of lines and then didn't actually do that. I just used the expression evaluator. It would feel a bit funny, so that's why. And then, yeah, that might run even quicker if we did that. But still, this is running fairly fast compared to the last time, so I think caching, turning that off did make a difference. But anyway, this has sort of worked out well, because what I was trying to show was that we don't necessarily need to use a loop for this for this exercise, and the cloner's working out just fine, even if it is sort of piling up the data. I bet there's some ways of speeding that up somehow, but anyway. All I got to do is hope it returns the right answer, and I don't have to sit around and debug this, because day 6 I spent a few hours trying to debug that, and it was really painful. Really painful. And then when I did 6B, well, I still haven't got 6B to work. It was taking so long. And then I got a quicker method and started to run it. And I got halfway through and thought, oh, I can think of a quicker method still. So I hit the stop button and the whole thing crashed, which wasn't good. Okay, so that's my result. Let's copy that, paste it in here, and I've got my fingers crossed so hard that this actually works. Bingo! Ah, that makes me so happy. Well, you can probably tell that. Yeah, that's what the quickest I've actually got one of those puzzles to work. The aggregator shouldn't be merging input attributes. It's certainly not generating a list. I mean, it's using attributes from one feature. I guess I could just say drop incoming attributes and it would be a lot quicker, but well, I'm happy with that, and that's great. So I don't think I'm anywhere on the leaderboard. It's certainly not on the main leaderboard. I've got 13 points and the leader's on 3,500. So, but we do have private leaderboards, the FME one. Oh, we've got 22 points rather, so anyway, I'm second on there, well behind Elizabeth there. She's just a machine, churning these out. Fantastic. Okay, I'm third at save, had a 5, so I guess people are dropping out as they as it goes along. Anyway, yes. Okay, well, that worked out well. So, but yeah, that's really what I wanted to show was, because again, just to summarize what I said at the start, somebody asked me about how lists work and what we should put in a training course and the content, and I sort of remembered this idea about loops and not looping by using lists and cloners instead, and so I gave that feedback, and then I looked at the puzzle for day 7. It's like, oh, wow, that's synchronicity. I can even use that for the same technique for this puzzle. So, and I could look at puzzle number 8, but I'm not going to do that right. Well, I might look at it. I'm not going to do it. Oh, wow. Okay, well, yeah, that's another puzzle. I will do that another time. But, yeah. Anyway, well, good to see some folk online today, and hope everything's good. I don't know if I'll stream again or do anything before Christmas occurs, so if not, happy holidays, Merry Christmas, whatever you celebrate in your part of the world, and yeah, hope to see you again in the new year. And yeah, I'll try and get a set schedule together so that it's easier to do. So, yeah, cool. Okay, well, take care, and see you in the new year. Okay, bye, folks.